Hello everybody and welcome back into Silent Hunter 5. We're inside the sub here, and in fact we're going to start one of the tutorials. The 4 bearing technique is something I've played around with in the past, but for the life of me I was not able to remember exactly each of the steps that I needed to do in the last contact that I had, which I don't think I recorded because it all went a little bit pear-shaped. So I've decided to run the tutorial for the 4 bearings, and we'll follow through it together. So we'll start
Machine
here.
stop.
So this tutorial, it says, will take you through a method to hunt shipping without any visual information being sent to your map. So this is kind of the immersive element of the cat and mouse game that goes on. Learning to attack ships with no map updates and using real navigation will add lots of immersion to your gaming experience. So let's get started. Click next here to continue. Remember, you can drag this box anywhere you like by doing that. And we get a picture here that we can drag by moving that around there. And note, you can scroll back through the tutorial at any time to repeat a stage. Okay. If you're using TDW's fade out for parts of your user interface, you may not see the highlight on the screen, so take note of that. And there are 5 stages within the tutorial, and it'll take about 30 to 45 minutes to complete. The 5 stages are map work, 4 bearings, the hunt, fast 90 setup, the attack. Okay. So stage 1 is the map work. Okay. So we're supposed to click here on this map here, and you can see that your map doesn't show very much apart from the navigation fix, and we would have been able to pull the navigation fix down from our navigator, who will tell us where we are in the map, and that's the only information we have. He'll have done this by Dead Reckoning, although it does seem that this was a celestial navigation fix that he set up. Okay, so we've got that from the navigator. Excellent. So now it says that this is an image that they have drawn, and they've drawn a line from the fixed position east for about 30 kilometers, and I've added a circle to the end of the line. Click next, or next will to remove this image and draw these things on your map. So we will click next, and we'll do this really quickly. So essentially we're drawing a line, so we can take the ruler out and we can put it over here, try and get it in the middle. There's an education point here. It says to draw out 30 on a 909 or 090 heading, actually. So we get it as close to 30 as we can, and there we go. And then it said it wanted a circle, so we go to the compass tool, and voila, we have a circle. So that seems fairly close to what we had before, or is it? It's very important that our map work is accurate when plotting for 4 bearings. When it comes to accuracy, the zoom is your best friend, so click next to continue. So you can see here how far apart your plotting can be if you don't zoom in. And basically what they've got here is the line that we drew and the center of the circle. And there's with zoom there's a bit of an error there. An easy way to zoom in: position your mouse over your plotted position and zoom in on the mouse wheel. Notice that wherever your mouse is, that's where the zoom in will be. So click next to continue. Well, we can do that here, and we can see that there's quite a gap. Oh my god. And if we zoom out and then zoom back in here, we can see there's quite a gap as well. Jenny, please zoom in on your position now. Well, we've done that, and we've realized that things are not looking as rosy as they do when we zoom out. Please select the ruler from your map tools and drag your line from the end point and position it accurately over your fix or over your position. Click next when you're done. So it says the ruler, and that's the ruler. So we click that, and then if we go to here, it'll go red, and then we can left click and hold, or we can left click, yeah, we can left click and hold, and we move it down until it's dead spot tickety boo right in there, and then we can right click and drop it off, and that is our position, which is not too shabby, I think. Overall that's pretty decent. Pardon me. Or we could just try and improve that a little bit. There we go. Click next to continue. Zoom out using the same process, and now accurately adjust for the circle. Well, we also saw that the circle was brutal. So if we leave the mouse there, and this is going to take me a little bit of getting used to. I go to the compass now. Compass. Where's the compass? Voila. Grab the end point and bring it over and just basically make the little crosses match up. That's there. That's not too bad at all. And now we have a drawing that looks similar to what we had before, but is much more accurate. Your map work will be a lot easier when you get used to doing this. That's for sure. Drawing parallel lines is required for the 4 bearings method. There is no tool option to allow you to draw parallel lines. So I will show you how to draw parallel lines using the compass. Click next to continue. So here's the drawing, and what they've done is they've taken the pointer of the radius and dragged it around and changed the size of the circle as well. But because the center of the circle was lined up on the end of the line, by bringing the pointer onto the line now, they've essentially, when you move the circle now, I see what they're going to do. I'll show you. Please drag the radius thing over there. Okay, so we need to go to compass. We need to highlight that there, and we need to just drag the pointer over to about there. And we do need to zoom in, because if we don't zoom in, we'll end up being off. So we look at the whole line, and we basically want it to cover over. And this is where a clean mouse pad and a clean mouse underneath is going to help, so you don't have any error in the mouse. So that's that bit done. So now we've moved the radius from here onto the line, and now we can adjust it with the compass tool. We can now move the radius line and in parallel to the other things to do. So what they do here is we go back to the compass again, but now we're picking up this end, and now we've got a parallel line. Et voila. Click next when we're finished. We are. The next area we will look at drawing multiple lines from the same spot. Now this is an issue that I had, which I fixed myself when I have enough patience to do it, but the solution wasn't, it's bloody obvious, and at the same point in time it took me more than a while to actually work it out. So this is required when we're adding 4 lines to our bolt position. So if we're having loads of lines emanate from here, what's the issue? Please zoom in. We zoomed in. You will notice that if you try and draw a new line on the spot, the only option you'll get is to move the old one. So if we go to ruler to draw a line and we go here, the old one lines up constantly. And this is a little bit of a problem. We only get the option to move the original line. If you move the mouse away, you can draw again, but that's no good because we want to start it on the spot. So what we do is we extend the line through the mark, just like that. And then we can draw the other line. And then it'll look like this. So to do that in practice, we would go back to our ruler, we would pick up the end line, and we would just pull it through the cross. Wherever you can see it, you can go as far as you like. And then we can pick another line by going right onto the center, and we can draw the second line down. This might be bearing number 2, for example, which I've pressed the wrong button and totally lost. So we'll do that quickly again. That's bearing number 2, and it's over the thing. Now, by the same measure, if we go to move bearing number 2 or bearing number 3, we'll end up having to move bearing number 2. So first and foremost, we can put it there, and then, and I use my right button to drop it, maybe I shouldn't, and now we can put in bearing number 3, and they all come from the same spot, and that's how that works. So that was cool. So now we look at different types of bearings, through, hydro, and scope. Click next. So through north is on here. So I have this tool here, we can look at it, and this is set up for through north. So north is 0 or 360 degrees, and it's at the top, and south is 180, it's at the bottom, and consequently on the left is the west, and on the right is the east. This is the type of bearing used for map work and setting headings, basically. So that's the takeaway. This is a true bearing. It starts at 0 in the north position or 360 in the north position, and it's used for map work and setting bearings. And that's the key thing to remember, which was one of the things I'd forgotten earlier. A hydro and a scope bearing will start from 0 and end at 360 at your bow, meaning it doesn't start from the north. It will start from wherever your bow is pointing. That'll be 0. So you're not talking a true bearing anymore. Obviously, you're talking a scope bearing or a hydrophone bearing or whatever. So Any bearing information you receive from the crew will be of this type. It does say that the radio man will give you bearings in both north and scope. Okay, well, I don't know, we maybe have to configure that way. Your navigator will give you true bearings. So we need to remember that. So in this example, if we are heading east on a 090 degree true, and we're true because north, we're talking about the inner circle here now on here, that's the most important thing to note. True north is pointing to 0, which is at the top, and if you go down 90 degrees and draw a line, that is the direction of our sub, and there's the background of our submarine, and it is going in the easterly direction. And we receive information from the sonar man saying that there is a contact at 350 degrees. So we're going to see it in this screen down here on the bottom right, and it's going to say contact, moving at a certain speed, closing or going away, and it'll give a bearing. And if that bearing was 350 degrees, we need to convert that to a true bearing so that we can plot it on our map, because it's not a true bearing that he's given us. What he's given us is a bearing that is relative to our boat. And this example shows that quite clearly, because if we now focus on the outside scale, we can see that the scope bearing is on the bow of our ship. This is the bow of our ship here, this is the stern. And if we extend that out, we can see that on the outer scale, 0 is on the bow of our ship. And he's given us a contact on a 350 bearing relative to the bow of our ship, which actually is there. And you can tell quite quickly that it's there, because the simple of it is that if you look at the true scale, or the true bearing, which is the inner scale, you can see that it's actually lined up with 80. And I've jumped ahead, so let me just get to that point here. The reason that's lined up with 80, and the outer scale is 350, which was called out, is because there's a very small amount of math, and it's highlighted in the box down here. You take the bearing that you are traveling on, your course bearing, and you add it to the contact bearing, and then if it's more than 360, you minus 360, and if it's less than 360, you don't remove anything. And if you do that math, and it's very simple, it's 90 plus 350, and in this case, because it's more, the total of those two numbers is obviously more than 360, we have to take 360 away, because we don't have to do 360. We'll still get back to 80 even if we try to put on 440 degrees. But anyway, if you do that, you end up at 80. And if you look here on the scale, and we'll look at it on this scale over here, our boat is traveling on a 090. So the outer scale is our boat, the inner scale is the true compass. So our boat is heading on a 090. So the boat will be, our boat bearing is 0, obviously on our bow. That's how we've set it up. But our true course is 090. So you can see both of those pieces of information with this tool. Now the heading that we were given for the contact, the bearing, excuse me, that we were given for the contact was 350. 350 relative to the direction of our boat, which is here, and the corresponding true angle of that is 80. So you don't even have to do this math. It'll tell you here if you just know that the bearing that you're given is this outside number, and you read the corresponding inside number to draw the line on the map. It's very good. It's very good. Very easy in that respect to do. Right. So, please use the eraser to remove all of the lines. So if we put the eraser there, we can get rid. We can get rid. We can get rid. And I think that's probably it. No, there's another one up there. We can get rid of that. And I think that is it. We've zoomed out on the mouse and we've zoomed back in. So what are we doing next? Stage 2 is the 4 bearings, and there's a picture of 4 bearings, which is hilarious. So how does the 4 bearings work? We have to click next to find out, shall we? If the target is moving at a constant heading and speed, we can use this predictability of constant heading and speed and do some trig, or very simple math, to get all of the information that we need in order to set up an attack, is where this is going. Click next for an example. So in this example it says that we're at 25 meters depth and we hear a long-range hydrophone contact. With our boat at all stop, we plot our first bearing. Click next. God, this is exciting. So in this picture, it seems that the bearing is directly to our... Well, where is it? On the map is a true drawing, so that the bearing is directly north. If our map position is blank, there's no fixed position, we need to add a mark for our position. It does not matter if it is correct or not, as everything we do will be from this point. Okay? So I like to go and actually get a fix on our position, and that is where our boat is, and that just kind of keeps things relatively straightforward. We don't actually necessarily have to do that. We can pick a dot that is anywhere we think we are, roughly. It doesn't have to be on the money. So absolute accuracy in that initial position where we're going to work from is not critical. What I tend to do is I go down and I get Emil here to say, Emil, do some math and tell, or do some dead reckoning or celestial stuff and tell us where we are. So if we're underwater, he's probably going to have to give us his estimate on his track and that he's been keeping log on, and he's going to put us somewhere close to being exactly where we actually are. That's good enough. Put a mark on the map where you think you are. Now let's say our heading is east, just as in the example. So our heading is east, so we're traveling a 090 course, and our first hydro contact is bearing 270. So we have to convert this to a true bearing. And if you remember, we add the contact bearing and our heading together, and if they are greater than 360, we minus 360. If they're not greater than 360, we don't do anything. Or technically we would minus 0, just to be the other end of that argument. So we draw our first line, which is basically a north bearing on this position, because we're heading in this direction and the contact is directly off our left or north, or what is our... Let's do this here. We are heading in this direction, which is east, and our contact is a bearing of 270. And if we add those two numbers together, we get north. That's just how it is, which is cool, because that is what it is. 0 or 360. Each bearing that we take from the contact must be timed. So you must start your stopwatch straight away. In this example, we will use 15-minute intervals. So essentially, when we hear the first contact, we start our stopwatch immediately. Then we can go ahead and draw it in, because we're using the time in the interval to do other things. But we need to start that stopwatch because we want to take a second and a third bearing, and we want to take those bearings at the same period of time apart from each other. So we've gone and we've drawn this and we've started the stopwatch. So the stopwatch is now running, and it runs until we get to 15 minutes. And the 15 minutes is counted here. There's a 30-minute scale on here, and this is the minute hand flying around, or the second hand, excuse me, flying around, and the minute hand is there. And so we're going to wait for this little needle in this little inset circle to go from its starting position down to 15. So it goes around to 30 minutes and then starts at 1 again, 2, 3, 4, 5, 15, all the way to 30, and then 1, 2, 3, 4, 5 to 30. So when it's down here at 15, then we're going to hit, we're going to ask the hydroman down here, for this guy, for another bearing, and he's going to come back and give us our next bearing, which is what's been drawn in here already. The first bearing was north. The second bearing is going to be no longer in the north. So we are already starting to get some information now. Oh, by the way, we haven't stopped the watch. We're going to take a third bearing, so we let the watch continue until it does another 15 minutes, which will bring the needle up to 30. And during that time, we're doing this plotting and doing this map work. And we will end up in this example with our bearing number 1 in red here, number 1 for this line, which is due north, and bearing number 2 which appears to be, a few degrees east of north. And we can already tell that it seems that, well, this was the first place we heard it, and now we've heard it somewhere over to the right. So we know that it is also traveling in an easterly direction. The same as we were before we came to a stop. We don't know how far away it is, but we do know that it's traveling from the west to the east. So after another 15 minutes, the 15 has now become 30, or the needle has gone up to 30. We will get another reading from the sonar guy, or the hydrophone man, or whatever, and we will plot that. And that will be our third bearing. And now that confirms that they're going away, but there's also another little bit of information here that's interesting. As soon as we get our third bearing, we need to move our boat to take the fourth. Now, for this we need to surface. And the direction doesn't really matter, but it's best towards and to the side of the last contact. What does that mean? This is our boat position down here. We've taken bearing 1, bearing 2, bearing 3. We've determined here that the boat is traveling from the west to the east. We don't know how far away it is, but we know that it's far enough away that it's not going to see us. So we surface the boat, and then we start moving in a direction that is towards the target. So we don't go straight at him, and we don't go straight west. I don't know what the example is going to provide, I don't recall, but we'll head in kind of this direction somewhere. We're just going to move the boat anywhere in this direction, kind of, I would say. Now we can actually get more. So the boat's surfacing, we're powering ahead on engines. We want to do at least, probably want to do 10 knots at least. Maybe we can do 11 or 12 knots. We do want to get ahead of this contact so that we can set up for him. But we don't really want to dilly-dally either. So what we are going to do also is we're going to run for 15 minutes. And that's important because the next bearing needs to be taken at the same period of time. Whilst that's all set up and going on, we can look at our chart and see what we can deduce, because there's some information here that's important. We can get even more information from this third bearing, as the distance from the second bearing to the third bearing, this longer green arrow, is greater than the distance from the first bearing to the second bearing, the shorter green arrow. And we can tell by the fact that this arrow is longer than this arrow, or the distance between bearing 2 and 3 is greater than the distance between bearing 1 and 2, it tells us that the contact is heading towards us. Might be coming like this, might be coming like this, might be coming like this, might even be coming like this. But it's coming towards our position. It's coming down this picture. It's not moving away up to the right, it's coming down to the right. Which means our position to move along here is a good idea to move along here to a certain extent, but we don't want to go up here, and we definitely don't want to. We don't need to go down here. We could, but we don't have to. We can just move along and maybe just move up a little bit. There is enough information to get a contact heading here. And we'll do a little bit of math on that for a minute. In order to work out the heading, we need to look at the second bearing. Now remember, we have 15 minutes here. The boat is moving, so we've got to get through this fairly quickly. We have to get through it accurately, but we can't be dilly-dallying. 15 minutes is on the clock, so we need to get going. In this tutorial, obviously, I'm going to blab away for the next hour. So we pick a point on bearing number 2. Where do we pick this point? The only guidance that it says is to pick it anywhere, but give yourself some room to work. What I think they're referring to is we could pick a point down here, in truth, but it kind of gets fairly tight, and there's not really an awful lot of room, and you're zooming in, and you're very, very tight in here. We don't have to go off the scale and be dramatic about it either. We're only going to get a line which is a heading. It's not a course. It's going to just tell us the heading. So picking an area up here where there's a bit more room to operate and just picking a point anywhere we like up here kind of makes sense, and that's where this mark has been made. So we've marked on bearing number 2. Now we're going to use that circle and parallel line technique. And what we're going to do is we're going to put a radius line on bearing number 3, which is here. And when we've set that up, then we're going to move it such that the line goes through that point that was on bearing number 2. And it's long enough that it crosses and intersects bearing number 1. We're going to do the same with bearing number 1. We're going to put the circle tool on here, the compass tool on here, draw out a radius that's directly on top of bearing number 1 line. Then we're going to pick it up in the middle and bring it over until that line intersects that mark on bearing number 2 that we started with. And we're going to make sure that the length of the radius is long enough for the radius line to intersect bearing number 3. That means now that we have a intersection line on bearing number 1 and an intersection line on bearing number 2, and we've been bearing number 3, excuse me, intersection line, and we've been using bearing number 2 as the reference. So now we can draw a line from the intersection point on bearing number 1, which was straight up, and the intersection point on bearing number 3, which is here. And because we know that the contact is moving from west to east, or left to right, we can draw a line that extends to the right. We know this is the heading of the ship, because we can come along with this and put it on there and measure it off as a true angle on the on the chart. And we need to probably extend this line a little bit further, but we know that this is the heading. Now this is not where the ship is, and that's the important bit. It could be on a heading. All of these lines are the same heading. It could be on a parallel line over here. It's not likely going to be on a parallel line here because we know the ship is going this direction. So it's going to be somewhere to the east of bearing number 1, 2, and even in bearing number 3 now because it's moved past there. But we don't know really exactly where it is. We don't even know where it is on this line, how far away it is from us. So it really could be anywhere. When we picked that bearing number 3, it could be anywhere on that bearing line. We probably would know that it was a little further away because of the sound being a little bit quieter. But we don't know where it is on that line. And we didn't know where it was on 2 or on 1. But we do know that it's heading on a ship direction, or a ship heading of 151 degrees. That's the cool thing so far. We can get more information. So this is the target's heading, is all this says, which I've already said. So at this stage, we need to predict the 4th bearing. Now this is a kind of a predicted 4th bearing. This is it's not the real 4th bearing because we haven't taken that from the ship yet. We're just doing some clever math. And the clever math that we're doing is we're going to put the compass on that mark number 2, and we're going to draw out a circle such that the circle passes through the intersection point on bearing number 3 and the intersection point on bearing number 1. They're labeled A and B on this example. And we're going to make that circle. You will find that the distance, the radius from A to the mark and from the mark to B are near about the same. And we can use that information to predict where the next bearing is going to be simply by picking up the circle, moving it down to the B point. In doing so, the circumference here, the outside of the circle, is going to track down here same distance as this arrow is, and we can draw a predictive line from the boat through that line all the way up here, and that will be our predicted bearing, which is our predicted number 4th bearing. Remember, we've moved the ship, so this is from where the predictive would have been if we hadn't moved the ship. So what you can see here is we've taken the circle which we started here and we've moved it down to the 3rd bearing, and we have looked where the circle intersects this extended heading line that we created, and we've drawn a line from the ship through that point and extended that up. So this is a predicted fourth bearing. It's not actually, it's not wrong, but it's not telling us really much more information, apart from we are going to be able to use it to identify where now on this bearing line the ship is, because we have moved the ship over here, and when we take another bearing from the ship over here, it'll be going up here somewhere and it'll intersect this line and it'll be telling us exactly where the ship is. So it says here that here is the predicted fourth bearing. That's referring to this red one here. Until we take the real fourth bearing, we can't set where along the blue lines the target course will be. So essentially that's what it was saying earlier. This line here that these yellow or orange or yellow or green arrows are on, this extended line here that I'm pointing at the end of, that can be here or it could be there, it could be anywhere here, and we don't know where that's going to be. But when we take the fourth bearing, because our ship has moved out here now, we'll be taking a bearing that'll put a line going up here somewhere, or up here, or maybe up here, or maybe even up here. I doubt it, but it might be. Then we'll be able to determine where on that predicted fourth bearing the actual position of the ship is. So another 15 minutes have passed, and we need to go and get the sonar guy to go and give us another bearing. Now in this example, I would have moved the ship probably over in this direction myself, because that's me, but in this particular example, I guess with experience you'll begin to realize when you do your circles where the likely intersection points are going to be, because this is the track down here. If I had started heading over here, I would have been heading over straight to the ship, or towards the ship, which I still think would have been okay. But they have moved the ship in a kind of a predominantly south-southeast direction, so this is now, after 15 minutes, where our new position of the ship is, and we've got that because we've asked the guy to do a dead reckoning. Time spent travelling at what speed and what direction, and draw that on the map. The sonar guy is now ordered to give us a new bearing, and after we convert the bearing to true bearing of 350 degrees, we draw the fourth line. So basically what's happened, so we've dived to get a new bearing. After we convert the hydro bearing to true bearing of 350 degrees, we draw it on the map. We draw it on the chart. Our boat is pointing in this direction now, and we've got a bearing and we've converted it to true, so 350 degrees off of here. Let's see where that line goes. Well, 360 is the north, 350 is actually back down here. How about that? So this line here was the course track. This was point A and this was point B, and we had done all of the lines and measurements on it and extended it out to there. We'd moved the boat down here. We'd had our predicted line here because we'd measured the time and we'd made all those gaps the same length. We had this predicted fourth line. We took a bearing. The bearing true was 350. We drew that 350 back until it intersected this predicted fourth bearing line to tell us exactly where the ship is. The ship is right there. And there you go. From this position of work, we can now find out the target heading, the target range. We can even find out the angle on bow if we want, or we can set up for that. And we can determine the speed of the target, which is basically the information you need in order to set up an ambush. We've measured the distance from point A, which is here, to point B. So from point A is on bearing 1, and this point here is no longer B, it's something else now, but it's the target position. And we know that that distance there is 1, 2, 3 times our period of 15 minutes, basically, which is 45 minutes. We can measure that distance, which in this example is 9,000 meters or 9 kilometers, and then we can use our charts to convert that into a speed in knots, which I think they'll show us in a minute. Our starting position for the first 3 bearings were here. Then after the third bearing was given, we surfaced the boat and moved with speed for 15 minutes down here before we took the fourth bearing. And during that trip, we did all of the extra little bit of drawing and stuff that was required here, including this predicted fourth bearing. We drew in the third as measured. We predicted the fourth bearing by measuring the same amount of time. And then when we took that bearing, we got our position from which we could then work out our speed. Really straightforward. Said a lot there, but it's relatively straightforward. Now we know we know the target traveled for 3 periods of 15 minutes, which was 45 minutes. And we know that the distance that it moved was 9,000 meters, so we look for 9,000 here. We don't see it. We see 8,332, and we see 9,720. So we have to kind of work out where do we think 9,000 meters would be. It'll be somewhere in that gap there, wouldn't it? And if we draw that line over, we can see that we're between 6 and 7 knots. Call it 6.5 if you're able to get away with it. Between 6 and 7 knots. You can err on the faster, I suppose, and you might need to accommodate for that if there's a big difference, but that's going to be good enough. So in this tutorial we've looked at 15 minutes between bearings. We can use any time gap we want. The longer the better, within reason. However, we need to also understand if the target is going away from us or coming towards us, and some of that, once you determine that it's going away, we might need to change our strategy. There is a lot of map work in between, only for the first couple of times until you get used to it, particularly between the third and fourth bearing, and it's important to give yourself enough time to do this. So that's also another consideration when choosing the period of time. Maybe 20 minutes period is a little bit better than 15. Those extra 5 might prove important. With practice, you could do it with 10 minutes, within 10 minutes. But remember, the further away, the slower the target, the longer the gaps. So this is all just practice that's going in. So if the speed is very slow, then we could use 30-minute gaps to get enough distance to make sense. So this was our starting position up here. There's a lot of lines disappeared now, but we don't need them. This was the position that we were in when we took the fourth bearing. We drew up that. We found that the track was coming down here as opposed to coming down over here or coming down over here. So we know that it's going to come down this line because this is its actual course now. It's not just its heading, but its actual course. And we know that because this fourth bearing intersected with the predicted fourth bearing at some point up here. And then we just drew the line down. And the line was a parallel line because we knew the course was 151 degrees, we just didn't know where. So in this image they've plotted a target course and added our ambush area. So the ambush area is here, essentially. And you can see that they've set up a fast 90 attack. Fast 90 attack means the boat is positioned 90 degrees or perpendicular to the heading of the target. So the bow of the boat is 90 degrees on, right angle. And it means that we can just fire out the tube straight away and we don't have to worry too much about anything. We just have to look for a point here to release because of the distance, which the TDC will tell us that, the tactical computer will tell us that. And then, yeah, it's sorry to the target because they're going to the bottom of the ocean and we'll be able to move off and do our thing. So with real navigation, we get to this area that we need to know the heading and the range. Excuse me. To get to this area, we do need to know the heading and the range. Well, we know the heading, but we don't know the range yet. But we can pick that up straight from the map. So we can use our ruler to do this, and it shows heading of 62 and a range of 4,200 meters. This is our heading and our range to the target's heading. We know the target's heading of 151 and we know the line. We know our position. So we know essentially what it is we need to do. We can measure off a distance and we can set a course that is going to put us 90 degrees on, and then we can move in to our ambush area, which is 4,200 meters. We would surface our boat and run that heading. How do we know how far to go with real nav, is a question. Well, we go back to the knots per meter per minute chart. And we know that we need to go 4,200 meters. We have to travel that distance. And we know that we will run at a speed of 10 knots. We've made that decision. We could run at 11. We could run at 12. We've chosen to run at 10 in this example. So we can use the speed chart now to tell us how many minutes we need to run for. And in this case, what's gone on here is we're not reading this top line at all. We're reading down here, we're looking for 4,200. This is 2,000 to 4,000. This is 3,000 to 4,000. This is, 4,100 to 600. This is kind of, the 4,200 is going to be somewhere here. And actually the 4,200 is going to be after that, and it's going to be, so it's not going to be row 9, but it's not going to be row 10, or it is going to be row 10, but it's not going to be 15 minutes of row 10. It'll be a little bit less, because we need to be, 4,200 is going to be here. 4,200 can't be between 2,778 and 4,169, but it just doesn't make sense, and that's too far to go here for 30 minutes. So you're just going to have to work this out by looking at it yourself a little bit, and you're going to see what is our speed. We're going to go at 10 knots. We walk this line over. This line is fixed because we've decided to go 10 knots. So we can trust that it's going to be on this line here. And we're looking for where 4,200 on this line is. And we see 3,000, 4,600. It's going to be somewhere between the two. 3,000 to 4,000 is about half. And we think there. And then we look up here and we think, well, okay, it's more than 10 minutes. It's less than 15 minutes. We think it's about 14 minutes. That's how that's done. So we arrive at our ambush area, and in this case we're going to set up a 90 degree like we discussed, and we wait for him to come in, and then bang. So in the next stage we're going to actually do this directly. The tutorial here on Silent Hunter 5 is very good because it's actually the real mission that has been augmented a little bit for this tutorial. So time is going to start moving on its own, and we're going to be walked through actually doing that ourselves, which I'm looking forward to. And then we will get to draw the lines, press the buttons, fire the torpedoes, and score a result. And some practice on this is going to be really, really good to do, because you'll be able to use it then more fluently when you're out in the open virtual ocean, fighting your war. Right, that's it for this video. Thanks for watching. Hope it was useful to talk through that. The tutorial is available quite easily under the historic missions options. Just select the tutorial at the bottom and then go to the historic options and run it. And yeah, enjoy. Until the next time, thanks for watching, and go handy.